Every time you use an app, data is moving through a network. And if data moves through something, that thing can be analyzed, monitored, or attacked. That's why networking is extremely important for anyone who wants to go into hacking or cybersecurity. In simple words, a network is just two or more devices connected together so they can share data.
Networks are mainly classified by size. A LAN or local area network is a small private network. Your home Wi-Fi, office network, or college lab are all LANs. They're fast, controlled by one person or organization, and this is where most internal attacks actually happen. Inside a LAN, attackers can perform ARP spoofing, sniff traffic, hijack sessions, or pivot to other machines. A WAN or wide area network is what you get when many LANs are connected across long distances. The internet itself is the biggest WAN, so whenever you access a website hosted in another city or country, your data is traveling through a WAN. Over WAN, hackers focus on MITM attacks, routing manipulation, and exploiting exposed services. A MAN, or metropolitan area network, sits in between LAN and WAN. It usually covers an entire city. Some ISPs and universities use MANs to connect multiple buildings or campuses across the same city. And at the smallest level, there's PAN, or personal area network. This is your phone connected to Bluetooth headphones, a smartwatch, or AirDrop. Very short range, very personal. So think of it like this. PAN is your personal bubble, LAN is your room or building, MAN is your city, and WAN is the world.
Data does not move by itself. It moves through networking. Networking devices are the doors and hallways controlling movement. Let's start with the simplest device. A hub just broadcasts data. When it receives something, it sends it to every connected device. No filtering, no thinking. It's like shouting a message in a room so everyone hears it. That's slow, insecure, and why hubs are mostly obsolete. But they help us understand why smarter devices exist. Next is the switch. A switch understands MAC addresses. It sends data only to the intended device, not everyone. This makes local networks faster and cleaner. Most homes and offices use switches. Now, the most important one, the router. A router connects different networks. Your home router connects your LAN to the internet. Routers work with IP addresses, not MAC addresses. They decide where packets go next, like GPS for data. Routers also handle NAT and basic firewalling, which makes them powerful targets. If a router is compromised, the entire network is exposed.
Now, let's talk about how devices actually communicate inside a network. Most of the internet works on something called the client-server model. In this model, one device acts as a client and other acts as a server. The client requests data and the server responds with data. The server is always online, always listening for requests, and usually has a public IP address. This is why servers are the primary targets for hackers. There's another model called peer-to-peer, or P2P. In this model, there's no central server. Every device can act as both a client and a server. Torrent networks are the best example. Instead of downloading a file from one server, you download pieces of it from many users at the same time. This makes P2P fast and efficient, but much harder to control and secure. Data never travels as one big file. It is always broken into small pieces. At the network level, these pieces are called packets. A packet carries logical information, like the source and destination IP address. Think of a packet as a delivery instruction saying, this data needs to go from this IP to that IP. The same data is wrapped into frames. A frame contains physical information, like source and destination MAC addresses. You can think of frames as local delivery, data moving from your device to the next router.
In the next videos, when we talk about IP addresses, MAC addresses, ports, TCP, and UDP, don't think of them as definitions. Think of them as levers hackers pull to control traffic.